Teleportation is REAL. The quantum revolution has begun.
Imagine, just for a second, that you could completely disappear from where you're sitting right now and instantly reappear in an entirely different location. No walking, no flying, never even physically crossing the space in between. It sounds exactly like a sci-fi movie, right? Like some futuristic teleportation chamber on a starship. Well, what if I told you that teleportation isn't just real, but it is actually happening right now? In the quantum realm, this isn't some wild fantasy. It is a fundamental operation of nature, and it's literally rewriting everything we thought we knew about the universe. Welcome to This Explainer. Get ready, because things are about to get weird, and honestly, this changes absolutely everything. Okay, let's dive into this because I know exactly what you're thinking. Are we secretly beaming people across the globe? No, we aren't teleporting humans. At least, not yet. But what nature is doing right now is teleporting information itself. You see, at its core, quantum teleportation is all about taking the exact, complete blueprint of a particle's properties from one place and manifesting it in a completely separate place. The actual physical particle doesn't travel the distance. Just kind of sit with that for a second. There's no physical material flying through the air or zipping down a wire. It is simply here, and then suddenly it is there. And that brings us to the ultimate locked room mystery of physics. Seriously, how can something move from here to there without actually moving? It sounds completely impossible. It goes against every single instinct we have about the physical world. You know, if I throw a baseball to you, it physically has to travel through the air to get to your glove. But down in the quantum realm, nature actually found a loophole, a hidden backdoor that entirely bypasses the space between 2 points. To wrap our heads around this deep mystery, we have to look at quite possibly the most mind-boggling phenomenon in all of science.
Section 1. The invisible connection. The answer to this whole moving without moving thing comes down to a mechanic we are only just barely beginning to grasp.
That invisible engine driving all of this is called quantum entanglement. When 2 particles become entangled, their fates get intimately, permanently linked across literally any distance. It absolutely doesn't matter if they are a couple of feet apart in a lab or on total opposite sides of the observable universe. If you measure one of them, you instantly, and I mean instantly, know the exact state of the other. It's as if they share a single invisible connection that space itself just cannot cut. This isn't just 2 particles talking to each other. It's more like a shared existence. That one invisible thread is what makes teleportation possible, totally shattering our everyday idea of movement. Now, when we talk about this kind of teleportation, we really need to clarify what is actually moving. It's the quantum state. Basically, this is the complete description of a particle's properties, its absolute fundamental identity. We aren't packing up a physical particle in a box and shipping it across the cosmos. Instead, we are using that invisible connection of entanglement to transfer the particle's complete quantum identity from point A to point B. The original particle's raw physical material stays right where it is, but its exact identity is transmitted and totally adopted by the receiving particle. But to really appreciate how crazy this is, we have to jump back in time. Section 2, Einstein's great doubt. Because yeah, even the smartest guy in history had a huge problem with this. The story of quantum teleportation didn't start in some glowing high-tech lab. It actually started in the mind of a man who famously refused to believe his own math. Back in 1935, Albert Einstein, along with Boris Podolsky and Nathan Rosen, published a paper digging into this exact phenomenon. And Einstein, he famously dismissed it. He called it spooky action at a distance. It was an idea so bizarre, so deeply unnerving, that Einstein genuinely thought it just proved quantum mechanics had to be broken or incomplete. He simply couldn't accept that 2 things could stay connected across vast distances, instantly influencing each other without anything crossing the space between them. But, well, decades of relentless experiments would eventually prove the great genius wrong. The journey to crack this quantum code basically spans 3 massive milestones. Starting in 1935, when Einstein planted his flag of doubt, scientists spent nearly 60 years trying to solve the puzzle. 60 years. It was this massive, suspenseful waiting game for the entire scientific community. Everyone was holding their breath, building up to a monumental breakthrough in 1993 that would literally rewrite the rules of reality. And that breakthrough brings us to a rather dark twist. Section 3, the rule of destruction, the ultimate magic trick of physics. So, in 1993, a team of 6 brilliant researchers, Bennett,
Brassard, Crépeau, Yoza, Perez, and Wooters published a paper that changed physics forever. They laid out a blueprint, a precise step-by-step protocol to actually teleport an unknown quantum state. They figured out that by using that spooky entanglement Einstein hated, combined with a very specific type of measurement, you can make a quantum state completely vanish at the source and instantly reappear on a particle far away. And you could do it all without ever directly measuring that identity. It was the ultimate magic trick, proven right there on paper. Information could be teleported. But there was a massive catch. Enter the roadblock that nearly stopped the whole thing dead in its tracks, the no-cloning theorem. This is a fundamental cornerstone of quantum science, and it lays down an absolute, unbreakable law. You are strictly forbidden from creating an identical copy of an unknown quantum state. You literally cannot clone it. Nature acts like an incredibly strict copyright lawyer here. It will absolutely not allow you to hit copy and paste. So think about it. If you can't make a copy, how on earth do you get the information from point A to point B?
So the crucial point is, the answer is destruction. It's not duplication. Duplication is forbidden. It is true teleportation. For quantum teleportation to actually work, the original state must be completely, irrevocably destroyed at the sender's location. The original is literally wiped out of existence. It isn't copied, it's moved. Teleportation actually demands a sacrifice. To perfectly recreate that exact quantum identity at the new location, the original version has to be totally erased. That's why it isn't cloning. That is what makes it teleportation. With this mind-bending, destructive theory now established on paper, the race was officially on. Section 4, Science Fiction Becomes Fact, the 1997 experiment.
Just 4 short years after that theoretical blueprint was published, the impossible actually happened. In 1997, a group of physicists in Innsbruck, Austria, led by Anton Zeilinger, finally proved it could be done in the real world. For the very first time in human history, they successfully executed this exact entanglement-fueled protocol. They teleported the polarization state of a single individual photon. They literally made its quantum identity vanish in one place and flawlessly reappear in another. Right there, in that laboratory, on that day, science fiction officially crossed over and became science fact.
Which leaves us staring down a deeply unsettling yet incredibly awe-inspiring reality. Just think about what we've uncovered in this explainer today. What does it truly mean for the very fabric of our universe if perfect, instantaneous travel actually requires the absolute destruction of the original? We aren't just passively observing the quantum realm anymore, we're starting to master its darkest, most miraculous rules. Sure, we might not be teleporting people just yet, but the keys to the universe, they're finally in our hands. So the real question now is, where is this invisible connection going to take us next?
Hey everyone, and welcome to The Explainer. Today we're jumping right into something that sounds, frankly, like pure science fiction, but it is actually happening right now in the real world. We're going to explore the absolutely mind-bending reality of quantum teleportation and look at how scientists are actively using it to build the global quantum internet. So get ready, because the way we think about data, communication, and, well, reality itself is about to be completely flipped on its head. Okay. Let's dive into this. Since you already follow the quantum space, you know the foundation relies on behaviors at the microscopic level. As a quick mental model, I want you to imagine 2 magically linked coins. You have one, and I have the other, and we are thousands of miles apart. But if your coin lands on heads, mine instantly becomes tails. That absolute, instantaneous connection, that is the bedrock of everything we're discussing today.
Section 1. The Magic of Entanglement.
To wrap our heads around this bizarre, invisible link, we have to look at a phenomenon at the absolute core of quantum mechanics, and that's entanglement. This happens when 2 particles become correlated in a way that just completely defies classical physics. Once they're entangled, they're no longer independent. They actually act as a single, unified quantum system spread across space. What happens to one inherently defines the other, completely regardless of the physical distance between them. It's wild.
Section 2. The Teleportation Protocol.
So, how do we actually use this strange phenomenon? Let's bring in the classic characters of literally every quantum physics story, Alice and Bob. Let's say Alice wants to send an unknown state of a particle to Bob, who is far away. The big trick here is they can't actually know what this state is, because in the quantum world, the act of measuring it destroys it. Instead, they have to rely on a quantum bridge. This is a precious entangled pair of particles, where Alice holds one half and Bob holds the other.
What follows is basically a carefully choreographed dance. First, Alice takes her unknown particle and performs a special Bell state measurement on it alongside her half of the entangled pair. This entangles the unknown particle with her half, but it destroys the original quantum state in the process. Now, this measurement yields two classical bits of information, which Alice then sends over to Bob. Finally, Bob uses those bits as instructions, applying a transformation to his half of the entangled pair. And just like that, his particle becomes an exact replica. The quantum identity has literally vanished from Alice's lab and popped right back up in Bob's.
Now, this process requires two essential components to work. The quantum channel uses that entanglement we talked about to transmit the state itself. But it also needs a classical channel to transmit ordinary communication so the receiver actually knows how to reconstruct it. It's kind of funny, actually. Even with all this mind-bending quantum teleportation happening, you still have to make a standard phone call, send an email, or shoot a laser pulse down a fiber so the other person knows what to do. Neither channel alone is sufficient. They are both absolutely essential.
So the crucial point is, because that classical information cannot travel faster than light, quantum teleportation does not violate Einstein's theory of relativity. The speed of light remains the ultimate speed limit of the universe. Yes, the quantum state transfers instantly, but Bob can't actually decode it until he gets Alice's classical message. Still, you have to admit, teleportation gets astonishingly close to making that cosmic speed limit feel completely irrelevant.
Section 3. From Lab to Space.
Up to this point, we've really been talking about microscopic, highly controlled lab environments. Let's move to and see how this builds on an epic global scale. Our timeline starts with the massive triumph of the Innsbruck experiment in 1997. By 2004, researchers managed to teleport a quantum state over 600 meters using standard optical fiber. But the most incredible leap happened in 2017, when a Chinese team beamed a photon more than 500 kilometers from a ground station in Tibet all the way to the orbiting Messias satellite.
What they achieved was nothing short of extraordinary. The photon didn't just travel through the atmosphere. Its quantum state was teleported directly across the vast void of space. It officially became the very first object ever teleported from Earth to orbit. Previous experiments were strictly limited to distances of around 100 kilometers, so this achievement completely shattered that limit, establishing a critical foundation for a true global-scale quantum internet.
Section 4. The quantum internet arrives.
Now, to make this technology genuinely useful, it has to work for us here on the ground, in our daily lives. Just look at this quote from Prem Kumar, the lead researcher at Northwestern University. He said, "Nobody thought it was possible." He was talking about a monumental shift that happened in 2024, right beneath our feet, which essentially made quantum communication practical for everyday infrastructure.
And this brilliantly illustrates why it was such a massive breakthrough. The team successfully teleported a quantum state through more than 30 kilometers of active fiber optic cable. And by active, I mean it was sharing a cable that was already humming with 400 gigabits per second of heavy real-world internet traffic. We're talking about incredibly delicate quantum states coexisting alongside your cat videos, your emails, and secure financial transactions. They managed this by carefully identifying a specific wavelength with minimal light scattering and installing precise filters to shield their fragile quantum signal from the overwhelming noise. And it worked. The quantum state emerged completely intact at the other end. So this proved we actually don't have to rewire the entire world to integrate quantum and classical networks. And the progress certainly didn't stop there. By early 2026, Deutsche Telekom and Connect repeated this unbelievable feat over a live commercial network in Berlin, achieving a seriously impressive average teleportation fidelity of 90%. Now, what's really interesting about this slide is the profound implication of Abdu Madir's statement. When he says, our fiber optic network is quantum ready, he's driving home the point that the global quantum internet is no longer just a sci-fi dream. It is actively being built right now, leveraging the very cables that already run beneath our streets and across our cities today. Which brings us to a final, provocative thought I want to leave you with. With the foundation of the quantum internet already running right beneath our streets, how will unbreakable quantum connections fundamentally alter the future of human communication? The possibilities for security, computing, and global connectivity are absolutely limitless. Thank you so much for joining me for this explainer. Keep asking big questions, and I'll catch you next time. Whenever we hear the word teleportation, our minds immediately go to the exact same place, right? We picture stepping onto some glowing pad, dissolving into a beam of light, and instantly materializing on a distant planet. Or, at the very least, just skipping the morning commute. It is the ultimate science fiction dream. So with all the absolutely incredible advancements in physics we're reading about every single day, the question on everyone's mind is, can we finally teleport humans? Well, the answer to that question reveals a reality that is actually much stranger and honestly far more fascinating than anything you've seen in the movies.
Okay, let's dive into the reality of quantum teleportation. What was once just a quirky theoretical curiosity scribbled on chalkboards has officially left the laboratory. It's entered the real world and become a highly practical tool with some profound implications for our future. We're not just talking about thought experiments anymore. We are talking about physical, measurable actions that are happening right now, transforming how we understand communication and really, reality itself.
Part 1. Teleportation is now real, leaving the laboratory. The dream of moving quantum information over long distances without any loss or disruption, that is now a proven reality. Let's look at how this builds across a truly breathtaking string of breakthroughs, all converging in the year 2025. In November of 2025, a team at the University of Stuttgart achieved something phenomenal: the first teleportation of a quantum state between photons emitted by two completely separate quantum dots. We're talking about entirely different light sources, physically separated, yet perfectly indistinguishable. As physicist Peter Mitchell pointed out, this was a worldwide first. It's a massive step for building quantum repeaters, basically devices that'll let these signals travel endlessly without degrading. And it doesn't stop there. That same year, researchers absolutely nailed chip-to-chip photonic quantum teleportation over standard optical fibers, and even achieved bidirectional teleportation, meaning two users simultaneously sending quantum states to each other within a single protocol. The pace of this progress is just staggering.
Which brings us to part 2. Why humans can't teleport, the science fiction pivot. Now, with all of that incredible momentum, I'm gonna have to hit the brakes for a second, because despite these massive technological leaps, the answer to human teleportation is, for now, a firm no. But it is absolutely essential to understand why it stays impossible. The hurdle isn't about moving physical mass, it is a data problem. The sheer amount of quantum information contained inside even one single human cell is unimaginably vast. It's a volume of data that goes so far beyond any technology we can even conceive of right now. Just think about it. To teleport a human, you would have to capture, perfectly map, and flawlessly transmit the exact quantum state of trillions of cells and the billions of atoms within each of those cells, all at the exact same time.
To put that into perspective, a rigorous 2025 analysis looked at the trajectory of our current technology and concluded that human-scale teleportation remains fundamentally improbable for at least the next 2 centuries. Our tech simply isn't there yet, not by a long shot. But here is the inspiring part, the silver lining in all this. It's not physically impossible. The laws of physics, as we understand them today, do not strictly forbid human teleportation. We just haven't mastered the physics or the engineering yet. What used to be considered literal magic is really just science waiting to be engineered.
And this brilliantly illustrates the huge disconnect between our imaginations and the actual science. Science fiction teleportation is all about moving physical matter, right? Taking a person, turning them into energy, and shooting those physical particles across space to be rebuilt. But real quantum teleportation is an entirely different beast. It's about moving quantum information without moving the matter that carries it. The particles themselves do not travel, only the information does. You are essentially transferring the fundamental identity of a particle to another particle incredibly far away without either of them ever crossing the space in between.
Part 3. The fragility of quantum states, the engineering nightmare.
To really grasp why moving human skill information is completely off the table for the next couple of centuries, we need to look at the underlying mechanics. The biggest villain in this story is a concept called decoherence. Quantum states are extraordinarily fragile. They're like a microscopic house of cards in a windstorm. If they interact with the outside environment in even the tiniest possible way, the quantum information is destroyed before it can ever be reconstructed on the other side. Literally a stray photon of light in the room, a microscopic thermal fluctuation, that's enough to cause decoherence. When you combine this extreme fragility with that unimaginable volume of data in a human body we just talked about, you get the ultimate one-two punch that makes teleporting a person practically impossible right now. Just imagine trying to perfectly protect the fragile quantum state of trillions of cells across space and time, when we're currently fighting just to protect a single photon from a slight change in room temperature.
I absolutely love this quote from a researcher highlighted in our sources. Teleportation doesn't solve the hard problems, it inherits them. Scaling up from teleporting a single photon to a complex quantum system, let alone a whole human being, is a monumental, almost insurmountable engineering challenge right now, because to pull this off, you need long-lived entanglement and absolutely extreme timing control. Every single problem we currently have in basic quantum computing gets multiplied infinitely when you try to teleport larger, more complex systems.
Part 4. The True Quantum Revolution. Reshaping Our World.
So, if we aren't using this to commute to work or visit other planets, what is all this incredible effort actually for? Because make no mistake, as we stand on the threshold of the quantum age, this technology will fundamentally reshape our world. This brings us to the future of the quantum internet. And this isn't just a slight upgrade to your home Wi-Fi. It is a completely new kind of network connecting entire civilizations. By teleporting information, we'll create unbreakable encryption for perfectly secure, instantaneous communication. It'll enable distributed cloud quantum computing, letting anyone anywhere harness quantum processors. We're going to see synchronized atomic clocks that will completely revolutionize global finance and navigation. We are talking about networks of quantum sensors so sensitive they can detect gravitational waves in deep space, and global networks capable of precisely monitoring climate change right here on Earth. Teleportation is the engine that's going to power all of this.
Ultimately, the realization we're arriving at here is profound. The universe is woven from information. Quantum teleportation teaches us that in the quantum world, information is absolutely everything. We're learning that the reality we inhabit is stranger and much more deeply connected than we ever imagined. The boundaries of what's possible are far wider than we dared to believe, and we are literally teleporting our future into existence right now, one photon at a time.
So I want to leave you with this final thought to consider. If the very fabric of reality is woven from information, and we now have the power to move that information without actually moving the physical matter holding it, what else can we move without moving? The quantum revolution has officially begun, and we are just scratching the surface. Keep learning, keep questioning, and thanks for exploring this explainer with me today.